guys, we're back again for another engaging earth science lesson. Today we're going to cover lesson 5, and that is called mountain building. Please do not submit anything to me via email unless I specifically direct you to do so. The only 2 things you should be submitting by the end of this week would be the 2 Achieve 3000 lessons that I assigned. That is it. Do not submit anything to my email address right at this moment, please. So today what we're going to do, we're going to start with our warm-up, and that's going to be plate movement. So what I'd like for you to do is copy down your warm-up like we always do, and then you're going to copy down your list of choices. Mr. Garcia told his 7th grade class that as a tectonic plate moves farther from a mid-ocean ridge, it cools and becomes denser. This can cause the plate to sink below another, less dense tectonic plate. The weight of the sinking plate then drags the rest of the plate downward. What is Mr. Garcia describing? Is it A, slab pull, B, ridge push, C, continental drift, or D, convection currents? So if you viewed the first lesson on YouTube, then you should be able to very easily answer this question. Alright, so we are going to talk a little bit about mountain building, and I am going to be posting the photos of the textbook into the webpage. I've put our photos into my albums, so there's a link on there under my albums because they are photographs, so it makes sense to put them in a photo album, just saying. So again, you're going to reference your textbook. You can fill in your definitions using those photos of your textbook. You're going to add the definitions to your notes, so you can start by copying down what I have here and then adding to them later on your own. So we're going to talk a little bit about mountain building. The first thing that we need to come across is the term deformation. If you take a look at the word deformation, what word do you see in deformation? You all should have responded, deform. So if you deform something, you change it, you alter it. So deformation is part of mountain building because it's where plates are either colliding and they are becoming deformed, they're changing. One type of deformation is folding. Okay? So that's when you have a collision and you actually have plates that are folding in and amongst themselves. The A, B, and C that I've drawn here each represent a layer of rock. And where that layer of rock is pushed up and you get a fold in an upward manner, we call that an anticline. And where it dips down, that is called a syncline. Again, please reference your textbook because that will become more clear to you. When it comes to mountain building, there are 3 types of faults. Okay, remember, a fault is a crack in the earth, or it's where 2 plates are either coming together, they are pulling apart, or they're sliding past one another. So we're going to start first with what's called a strike-slip fault. And in a strike-slip fault, you'll notice that I have 2 arrows that are going past each other. What kind of boundary exists when you have 2 plates sliding past each other? You all should have said transform boundary. Okay? So strike-slip faults, that's where rocks strike, tension builds, and then poof, there's a slip. Okay? The type of stress that's associated with this is called shear stress. I'm going to ask for you to go to your textbooks to define the term shear stress. The second type of fault is called a normal fault. And it's called a normal fault because the rocks or the slabs act the way they normally would in lieu of gravity. So what happens here is this happens at a divergent boundary. So if you notice, the arrows are pulling away. So this is a piece of lithosphere, this is a piece of lithosphere. These 2 pieces are pulling away from each other, but as they do so, they drag past each other. The hanging wall is dragged downwards, the foot wall is pushed upwards. So there's this kind of motion as everything's pulling apart. The type of stress that's associated with a normal fault is called tension. And again, please go to your textbook and put down the book definition of what tension is into your notes. The third and last type of fault is called a reverse fault. And it's called a reverse fault because it behaves opposite of what a normal fault would do. So normally in a normal fault, the hanging wall slides down. The hanging wall this time gets pushed up. This is because the two plates are coming together at a convergent boundary. The foot wall slides down and the hanging wall slides up. And the stress that's associated with that is called compression. Again, go to your textbook and write down the book definition for compression. The last thing we're going to talk about are the three different types of mountains. So what I've done is I've made 3 columns, and I've put the type of mountain at the top of each column. Folded mountains, volcanic mountains, and fault block mountains. So if you just take a look at the words at the top of the columns, you'll get a pretty good idea of what each mountain's going to look like. Folded mountains occur when you have 2 plates colliding and the layer of rock just fold up. It would be like taking a towel and pushing the ends together and the layers just fold up. Volcanic mountains occur because magma is rising through the Earth's crust. It erupts onto the Earth's surface and it simply trickles down the sides, cools off, and a mountain builds from there. And the last type of mountain is called a fault block mountain. And that's where you have chunks of lithosphere and they stick up like blocks because there's a fault, and along that fault there are blocks of lithosphere. Tension makes rock break along normal faults. And that's it for lesson 5. Moving forward.